In the summer of 1942, an American intelligence officer sat in a hangar in Alaska, staring at the most valuable piece of wreckage in the Pacific War. It was a Japanese Zero fighter, nearly intact, belly-landed in a bog on Akutan Island after its pilot died from ground fire and slumped forward on the controls. The Americans pulled it out of the mud, repaired it, and flew it. For weeks, test pilots put it through every maneuver in the book. They dove it, rolled it, pushed it to its limits at high speed and low speed. They measured everything. And when they were done, the classified report they wrote to Washington did not say what most people would expect. It did not say the Zero was unstoppable. It said the Zero was beatable. And more importantly, it said exactly how. That report was the beginning of the end of the Zero's legend. But the legend itself, the story of the untouchable silver fighter that humiliated the Allies for the first year of the Pacific War, is still the version most people know. The romanticized version. The Hollywood version. The version that treats the Zero as a marvel without asking the one question that actually matters. Why did the nation that built it lose the air war so completely and so fast? The answer is not in the cockpit. It is not in the dogfight statistics of 1941. It is in the industrial ledgers, the pilot training records, and the raw material shipping manifests of 1942 and 1943. It is in a set of strategic realities that the Japanese High Command understood intellectually and refused to act upon emotionally. The Zero was not beaten by a better fighter, though better fighters eventually arrived. The Zero was beaten by a system, an American industrial and logistical system that Japan's strategists had calculated, had measured, and had dismissed as something a nation of shopkeepers could never actually execute. They were catastrophically wrong, and the Zero's pilots paid the price. To understand what actually happened, you have to go back to the fundamental design philosophy that created the Zero. In 1937, engineer Jiro Horikoshi was handed a specification that was, by the engineering standards of any nation on Earth, impossible. Maximum range, maximum climb rate, maximum maneuverability, minimum weight. You cannot have all of these things simultaneously. Physics refuses. Every aircraft is a negotiation between competing demands, and every choice you make in one direction costs you something in another. Horikoshi made his choices. He deleted the self-sealing fuel tanks. He deleted the armor plate behind the pilot's seat. He used an experimental ultralight aluminum alloy that reduced structural margins to levels that made Western engineers uncomfortable when they later examined captured examples. He built a plane that could do everything the admirals wanted in the air, and that offered its pilot almost no protection when something went wrong. The rationale was coherent within its own assumptions. Japanese naval doctrine in 1937 assumed short, decisive engagements. The elite pilots who would fly the Zero were trained to never be hit. In the context of the China campaigns, where Japanese pilots faced poorly trained opponents in inferior aircraft, that assumption held. A skilled pilot in an unarmored aircraft is dangerous. An average pilot in an unarmored aircraft is a statistic. The admirals built a weapon for the first type of war. They got the second type. The kill ratios of December 1941 through mid-1942 were real, and they were spectacular. At Pearl Harbor, at the Philippines, over the Dutch East Indies, the Zero's experienced pilots performed exactly as advertised. Allied pilots who survived those early encounters reported a level of performance that their own commanders initially refused to believe. There are documented cases of intelligence reports about Zero capabilities being dismissed as pilot exaggeration by officers who could not reconcile the numbers with their assumptions about Japanese technology. That dismissal cost lives. The Allies had months of warning from pilots who had seen the Zero over China, including Claire Chennault, who sent detailed performance reports to Washington that were filed and forgotten. But the critical variable, the one that the Zero's mythology consistently obscures, is that those kill ratios were produced by a specific, finite, irreplaceable group of men. Japan's pre-war pilot training program was one of the most rigorous in the world. Candidates were selected from thousands of applicants and subjected to a training regimen deliberately designed to break most of them. The pilots who survived it were exceptional. They had thousands of flight hours. They had combat experience over China. They knew the Zero's capabilities and limitations with an intimacy that cannot be replicated in a classroom or a simulator. Japan entered the war with approximately 3,500 of these men, and the Zero's design, with its absent armor and unprotected fuel tanks, meant that when those men were hit, the plane gave them no second chances. American gunnery data from 1942 is consistent on this point. A Zero that was struck by incendiary rounds in the fuel system typically became uncontrollable within seconds. There was no self-sealing tank to slow the fuel leak. There was no armor plate to protect the pilot from fragments. The plane that was nearly impossible to hit in a turning fight gave its pilots essentially no survivability margin once it was hit. The attrition among Japan's experienced pilot corps through 1942 was catastrophic, and, from the Japanese strategic perspective, irreversible. Japan's pilot replacement pipeline was not built for a war of attrition. It was built to produce a small number of exceptional aviators over a long training period. Shortening that pipeline produced pilots who could technically fly the Zero, but who lacked the instinctive mastery of its performance envelope that made the plane dangerous. A novice pilot in an unarmored aircraft engaging an increasingly well-trained American opponent in increasingly capable American aircraft was not a continuation of the 1941 kill ratios. He was a different statistical reality entirely. Meanwhile, on the other side of the Pacific, the American response to the Zero was methodical, industrial, and relentless. The Thach Weave, the tactical counter developed by Commander John Thach, exploited the Zero's documented high-speed roll rate degradation. Above 300 miles per hour, the Zero's ailerons stiffened severely, limiting its ability to roll and follow a target through a high-speed brake. Thach turned that engineering compromise into a defensive formation that denied the Zero the slow-speed turning fight it required to dominate. The tactic worked. It was not complicated. It was based on reading the actual performance data instead of the mythology. The F6F Hellcat, which entered combat in August 1943, was the industrial answer. It was heavier than the Zero by nearly 2,000 pounds. It was not as nimble at low speed. It did not turn as tightly. None of that mattered. It was faster in a dive. It was better armored. Its pilot had a seat plate that could stop a rifle-caliber round. Its fuel tanks were self-sealing, and it was being produced at a rate that Japan could not mathematically comprehend. By 1944, American factories were producing more aircraft in a month than Japan produced in a quarter. The pilots flying those aircraft had training programs that had been scaled aggressively, producing competent aviators far faster than the Japanese model permitted. The individual American pilot of 1944 was not the equal of Japan's 1941 veteran. He did not need to be. He had a better plane, better radar support, better logistics, and a replacement waiting if he was lost. The operational data from the Battle of the Philippine Sea in June 1944, what American pilots called the Great Marianas Turkey Shoot, encapsulates the entire arc. Japan committed its remaining experienced aviators and hundreds of aircraft in what was intended as a decisive engagement. The Americans, with Hellcats, radar-guided intercepts, and coordinated fleet air defense, destroyed 92% of the attacking aircraft in a single day. Pilots who had spent years in the training pipeline were gone in hours. Japan lost 3 carriers and nearly 400 aircraft. The Americans lost 29 planes. The disparity was not about individual skill or individual aircraft, it was about systems. Japan brought a fighter. America brought an industrial machine that ate fighters. What should have been Japan's strategic planning response to the growing evidence of American industrial capacity, and that evidence was available from 1942 onward in the captured documents, the prisoner interrogations, the count of ships appearing on the horizon, was adaptation. Newer Japanese fighter designs existed. The Kawanishi Shiden addressed the Zero's key weaknesses. The Mitsubishi A6M Zero was designed as a direct successor. Both aircraft were ready in prototype form by 1943. Neither entered production in meaningful numbers. Japan's industrial base, strangled by American submarine warfare that was systematically destroying the merchant shipping carrying raw materials from Southeast Asia, could not shift production. The aluminum that should have built new fighters was on the bottom of the Pacific. The factories that could have tooled up for new designs were running out of materials to feed the existing production lines. The Zero was not just a plane by 1944. It was a symbol of an institution that had optimized brilliantly for one type of war and found itself unable to adapt when that war became something different. The pilots who flew it against Hellcats in 1944 and 1945 knew its limitations. Some of the most experienced survivors had been filing reports about those limitations since 1942, watching the reports disappear into a command structure that was psychologically unable to process the information they contained. The warrior spirit that the imperial system valued above logistics, above industrial planning, above raw material accounting, was a cultural orientation that produced extraordinary individual performance and catastrophic institutional failure. The Zero remains one of the most remarkable aircraft designs in the history of aviation. What Horikoshi achieved within his constraints was genuinely brilliant. But the constraints themselves, and the refusal to revisit them as the operational reality changed, turned a masterpiece of engineering into a strategic liability. The pop history version tells you Japan almost won the air war with the Zero. The operational data tells you something colder. Japan built a perfect weapon for a short war and fought a long one. They built a weapon for elite pilots and lost those pilots faster than they could replace them. They built a weapon that demanded industrial sustainability and ran out of the raw materials to sustain it. Those are not romantic failures. They are logistical failures. And in the mathematics of industrial war, logistical failures are the only kind that actually decide the outcome.